So today we will discuss one sum on standard deviation, which is similar only. So we will just discuss it. No need of solving it. You can understand it. See, standard deviation calculation. Project X, project Y, two projects are given. NPV estimate is given and corresponding probability distribution is given for both the projects. Okay. NPV estimate they have given and probability values they have given, and 4 questions they have asked. Compute the expected net present value of both project X and Y. Very simple. Risk attached to, that is a standard deviation you have to calculate. Okay. Then which project is more risky? Very simple question, and compute the profitability index of each project. Okay. So these 4 questions are there. All are very simple questions. We will try to discuss fast. See, first question is what? Compute the expected net present value. Very simple. How we will calculate the expected net present value? NPV estimate is given. Just multiply with the probability value and add that value. You will get the expected NPV, which is called as ENPV. Expected NPV. Just multiply the estimate, NPV estimate, with the corresponding probability value and add that value. You will get the estimated or expected NPV. So everybody calculate for project X fastly. 3000 into 0.1, 6000 into 0.4, 12,000 into 0.4, 15,000 into 0.1. So total will be the expected NPV. Similarly, you can calculate the expected NPV for project Y also. Multiply it by the corresponding probability and add that value. You will get the expected NPV for project Y. So calculate everybody fastly. So for project Y, it will be 3000 into 0.2, 6000 into 0.3, 12,000 into 0.3, 15,000 into 0.2, total. Calculating everybody. See, estimated NPV for project X is 9,000. Simple, multiply the corresponding probability value and add that values. You will get the expected NPV for project X. And for project Y, it is again 9,000 expected NPV. Clear? Now, next question is what? Risk of the project. Risk will be calculated using which? Standard deviation. So standard deviation will be, what are the steps for calculating standard deviation? X probability, X into P, average, then X minus X bar. Expected NPV is also called as X bar average. We know that already we have discussed. So expected NPV will be average, right? And keep expected NPV will be average or mean. That is X bar. Okay. So X minus X bar, 3000 into 9000. So this table will be X minus X bar. So 3000 minus 9000, 6000 minus 9000, 12,000 minus 9,000, 15,000 minus 9,000. Then square this table, multiply this by the probability value, you will get the variance. This will be variance. Okay. Square root of variance will be standard deviation. So similarly, for project Y also you can calculate the variance and standard deviation. Clear? This is similar to the sum we have already discussed. While selecting the project, we will select those projects which is having the low standard deviation. Clear this much, everybody? So today we will understand a special situation in capital budgeting, which is known as a scenario analysis. Okay. Scenario analysis. This is also a topic under risk management only. Risk management in capital budgeting, or capital budgeting under risky situation, or using risk under, under capital budgeting decision. It is a part of that topic only. Scenario analysis. Very interesting actually. Scenario means what? Scenario means alternatives. Okay. Scenario means what? Alternative situations. Okay. Scenario means what? Alternative. So one way to examine risk of investment is to analyze the impact of alternative. See, they also call it as alternative. Scenario means what? Alternative situations which may arise while doing the capital budgeting decision. Okay. So in scenario analysis, we will analyze the NPV of a project under three different situations. So scenario, there will be three cases will be there. Okay, what will be the NPV in the best case? Okay, if the situation is very best, environment situation, political situation, social condition in the country, economy are very good, what will be the NPV? If the situation is worst, everything is bad, what will be the NPV? If it is medium, that is average case, then what will be the NPV? Okay, for this three cases, we will analyze the NPV separately. What will be the NPV in best case, in worst case, and median case, average case? So this is known as optimistic. Means very best situation is called as optimistic situation. Okay, so optimistic is a person who is always positive, you can say, who will think of the best case. Optimistic situation, pessimistic situation. Pessimistic means you can say worst case or negative situations. Pessimistic person we will say, and most likely situation. This means average. It will lie between both optimistic also and between pessimistic. That is a normal, we can say, normal behavior, most likely case. So in these three cases, we will calculate the NPV, analyze the NPV in optimistic situation, in pessimistic situation, and most likely situation. So this analysis in three different cases, optimistic, pessimistic, and most likely, it is known as a scenario analysis. Okay, so see, let us understand this illustration. Mrs. Deepika, the chief financial officer of Divya company, is considering the investment of rupees 42,000 in a machine. So Mrs. Deepika is that she is the chief financial officer of a Divya company. She wants to take decision of investing rupees 42,000 in a machinery. Okay, it is depreciated on fixed installment, means a straight line method is used. 7 years is the economic life. Rate of discount is 13%, tax rate is 35%. So all these details are given for us to calculate the CFAT. If you will remember our initial discussion, what is relevant for analysis is the cash flow after tax. So using these details, we will calculate the cash flow after tax. Sales unit is given, selling price is given, variable cost is given, and fixed cost is given. Okay, under three different situations. Pessimistic situation. If the situation is not good in the country, then sale will be 2,300 units only you can sell. If it is average, that is most likely, then average situation, normal situation, you can sell up to 2,500 units. If you make an optimistic expectation, that is, you assume that everything will be correct in the coming years, then the chief financial officer has estimated that you can sell up to 2,700 units of your product. The three different cases, very logical. Pessimistic is less than average, little increasing, and in optimistic, you have made a very positive expectation of your sales. Okay, units. Similarly, selling price per unit is also based on this expectation only. See, under pessimistic assumption, you are assuming that 38 will be your selling price per unit. In most likely, you are assuming that you can keep up to 40 rupees per unit. And in optimistic, very good expectation, you are keeping your price 40. Similarly, variable cost data are also given and fixed cost data are also given. Three different scenarios or situations. So we have to calculate the NPV in each of the above scenario. Understood everybody this much? The illustration everybody understood? Simple only. Normal NPV only we have to calculate, but under three different situations. Clear? Any confusion? Okay. So first what we will do, we will calculate the cash flow after tax. So first we will calculate what CFAT, cash flow after tax, calculation of CFAT. Three different situations. Particulars. Pessimistic. Most likely, for that they have used the word expected and optimistic. First, we will calculate the cash flow after tax. So is the units 2,300. Sales will be, you can calculate it like this. Sale units selling price. Sales into selling price per unit, you will get the total sales. Then this variable cost will be units into variable cost per unit. The variable cost per unit is given in the question. See, 21, 20, 90. Into 21, 2,500 into 20, 2,700. Yes. 30, 28. Yes. Depreciation. Depreciation will be how much? It is fixed line, straight line. So 42,000 divided by 7 will be the depreciation amount. Straight line method, fixed installment. Straight line. No depreciation. Depreciation will be rupees divided by 7 years. So it will be rupees 6,000. Depreciation 6,000 in all the three cases. Before PBT. Okay. PBT is sales minus variable cost minus fixed cost minus depreciation. Less tax at the rate. Tax at the rate 35%. Okay. Less tax at 35% will be 35% of profit before tax. So profit after tax PAT will be PBT minus tax. Then one thing we have to do, add back the depreciation for calculating cash flow after tax. Same depreciation only we have to add back. PAT plus the depreciation will give the cash flow after tax. This is the cash flow after tax under three different situations. Now we will use this cash flow for our NPV calculation. Cash flow CFAT. Now we can calculate the NPV. First we will calculate in pessimistic, or we will calculate it in same table only. We can do here PV factor, PV factor That is a PV factor percentage, 13%. PV factor is, discounting factor is 13%. Okay. So first case will be pessimistic. Most likely that is expected, and optimistic. Pessimistic, expected, and optimistic. Okay. Cash flow, discounted cash flow, cash flow, discounted cash flow, and discounted cash flow. Here, 0 initial investment, 1, 2, 3, 4, 5, 6, 7. 7 years is the expected life of the project. 0 discounting factor will always be 1. Initial investment is how much? 42,000. Clear? Then everybody calculate this fastly. 13% discounting factor. Anybody put it in the message box? 13% discounting factor from 1 to 7th year. Nobody is calculating. 13 divided by 100 plus 1 divided by equal to. Zero point 8849, 0.7831. No, not the total, individual. 0.6930. 0.6133. 0.5427. 0.4803. 0.4250. Okay, thank you. So now we have got the discounting factor. Here you can do shortcut method also. Since cash flows are same, so what you can do, you can calculate this in calculator, do M plus MRC, you will get the PVIFA and multiply it by the cash flow and minus it by the initial investment. That is a shortcut method that we have not discussed. We will go by the long-term method only. Okay. So those who are comfortable with that, they can use that shortcut approach also. So see, every year cash flow will be same only. For all the 7 years, under 3 different cases, we will take same cash flow only, because no other data is given. We will assume that all the year data is same. So for pessimistic case, all the 7 year, we will take the cash flow as 6715, which is this. And expected case, we will assume that the cash flows for 7 years are same, 15,100, which we have calculated. And for optimistic, we will assume it as 24,265, which we have calculated. Because no other data is given, so we will have to assume that for all the 7 years, CFAT is the same only. Okay. So now we can calculate the discounted cash flow. Multiplied by the PV factor, we will get the discounted cash flow. Here, discounted cash flow will be same only. Now you can calculate the NPV. How you can calculate the NPV? NPV will be, okay, for that we will have to do the total of the discounted cash flows. Inflow minus outflow. NPV will be inflow minus outflow. In pessimistic situation, NPV is negative. In expected situation, NPV is positive. And in optimistic situation, NPV is positive. Okay, so this is the NPV under 3 different cases. Net center NPV. Clear, everybody?